Greetings, everyone, and this is Mr. Mullen. In this short podcast, I'm just going to talk about electric current, which is the rate of flow of charges through a cross-section of some conductor. So I'm going to use a PHE simulation here. Here's a little copyright status. I just want to give them credit for the simulation I'm using. So I've got a battery here, and a battery is a source of voltage. We're going to talk about that, but basically it's something that can push electrons. So I'm going to go ahead and push electrons through a wire, and I'm going to put a little resistor in here so that I don't short circuit my wire. My electrons are going to have a little obstacle. They're going to have to be pushed through the filament of this little light bulb. So here we go. You'll notice my electrons are getting pushed through in my little light bulb. They're coming in the side. They're going down to the bottom. I've got a complete path for a charge to flow. This is a continuous conducting path. And so if there's a continuous conducting path, my electrons are able to flow through a conductor if there's something that can push them. So a battery acts as a little electron pusher. And so if I kind of zoom in on a little area of, I'll get my little ammeter here. There's my little ammeter. I'm going to I need to put an ammeter in here. So I'm going to put an ammeter in here. Now, in order to do this, I'm going to actually have to stick my ammeter in the circuit. That way, electrons can flow through it, and it can read how much is flowing through. So, as you can see, if I look over this little amp box here, this is an ammeter. It's measuring the flow of charge going through it. And the flow here looks like it's going to be 0.90 amps. Now, amps is a unit that is equal to a coulomb per second. So 0.9 coulombs of charge are flowing through this little cross-sectional area every second. So I'm going to talk a little bit about the math of circuits, but I wanted to show you a simple circuit and show you electrons flowing through it so you can kind of visualize this as we start our discussion on circuits. So let's go ahead and talk about electric current. So electric current we are going to define as the rate of flow of charges. Rate, let me use a different color here, of flow of charges. And this is going to be through some cross-section of a conductor. Okay, so the equation that we're going to use for current is given by the symbol I. Okay, you can very much think of it like current in a river, okay, except the rate of flow of gallons of water over some amount of time. This is the rate of flow of charge. Okay, so here we have delta Q. This is going to be the magnitude of charge, how much charge is flowing through a cross-section. This is going to be our time interval. So this is our equation that we can use to describe the rate of flow of charge. The standard unit for current is the ampere. The symbol uppercase A is going to be the unit symbol. And 1 amp is defined as 1 coulomb per second. Okay, so charge is measured in coulombs per unit of time seconds. Coulomb per second is defined as an amp. Okay, so we saw 0.9 amps or 0.9 coulombs per second flowing a second ago. Alright, so here's just a little quantitative example. In a certain wire, there are 1.25 times 10 to the 13th electrons that flow past a certain point over the course of 10 minutes. What is the electric current in the wire? Okay, we're solving for I. So we've got current. It's going to be the rate of flow of charge. So to figure out what my charge is, I'm charged in coulombs. So electrons are not a unit of coulombs, but electrons carry a charge. So I can use how many electrons I have, 10 to the 13th electrons, and I can use the amount of charge per electron. So I can look at my little reference sheet, and it's going to be 1.6 times 10 to the negative 19th coulombs of charge per 1 electron. Okay, we can do a little conversion there, a little dimensional analysis. So that's going to give me the charge up top, and then I've got 10 minutes. So I've got my 10 minutes times 60 seconds per minute. And here we have a nice fun problem. So when I multiply all those out, I'm going to get 2 times 10 to the negative 6 coulombs over 600 seconds. And that's going to be 3.33 times 10 to the negative 9th amps, or coulombs per second. Okay, that's going to be my current flow. So just kind of pointing out here, something I already mentioned, I actually needed the change in charge, how much charge was flowing through. I need to actually measure the amount of charge, not number of electrons. Okay. Just kind of pointing that out here. All right, so this has just been a very brief little example of electric current, and I hope that this has been helpful.